Okay, so far we have written proper skeleton equations for chemical reactions, meaning we have the proper formula written for every reactant and product. And then from those proper formulas, we have balanced the reactions. According to the law of conservation of mass, we had to make sure we had the same amount of reactants going in as products coming out. The last little piece of the puzzle here is that a lot of times, especially obviously in print, we see that chemical reactions have symbols beside each of the species. And what these symbols do is tell us what is the state of the substance that is in the chemical reaction. And it also will tell us some stuff about whether or not we perhaps heated up a reaction. So here you see some common symbols that we will use in class. So if there's a little S in parentheses next to a species in the reaction, then that means that that species is a solid in its solid state. If there's a little L, then it would be liquid. If there's a little G, then it would be gas. Now with gas, yes, we could see the little g, but we might also see an arrow pointing upwards, which is another way that we symbolize that we have a gaseous substance in a reaction. Now, if you've done your little web assignment before we do our 10 test tube mystery, you've seen these words, aqueous and precipitate. Okay, and so these are important, especially with double replacement reactions. But remember, aqueous, there'll be a little AQ in parentheses, and that's a fancy way of saying that something is dissolved in water. For a precipitate, you will see a downwards pointing arrow, because typically what happens when you mix some aqueous compounds, a precipitate will form and sink to the bottom. So you'll see a downwards arrow next to the substance that is the precipitate. The other ones we'll look at right now is that if we see the word heat, or if we see a triangle above the arrow, that means that a reaction has been heated up. Eventually, if there's a chemical formula written up there, it's going to symbolize that a catalyst is used in the reactions. But we don't have to worry about that till later, so don't worry about that right now. Let's just say that if we see the word heat or a triangle, the reaction is heated. So here's our little example. It says, when molten sodium and chlorine gas are combined, solid sodium chloride is produced. I know, how many times we're going to look at this reaction between sodium and chlorine making sodium chloride. And so when you look at this complete, balanced, jazzed up reaction, you see that molten sodium, that means the sodium is in a liquid form. Chlorine is gas. I have the little g there, or I could have put an upwards arrow. Doesn't matter which, so this one has the g. It's combined, and we end up making the sodium chloride, which is solid. Okay. If you remember from our examples, we had to heat up the sodium to get it molten, which is why I put a triangle there to symbolize that this was heated. It didn't specifically say it in that sentence, but we've seen that reaction so many times, we know that it was heated up. All right, so let's look at an example here where I give you all of the information. It says add symbols to these reactions. So I see solid sulfur burns an oxygen gas to form sulfur trioxide gas. So all I simply have to do, solid sulfur, I put a little s in parentheses. You try and make it smaller and written down by the subscript if there is one. So we don't want to make it huge, we just try and keep it small and down to the right of the formula. Oxygen gas, okay, so I put a little g. Sulfur trioxide gas, so I put a little g, or I can put an upwards arrow. And it says that this is burning, so I would probably put a triangle or write the word heat to symbolize that this reaction was heated up. So if I give you the reaction or the formulas, then that's all you have to do. To make it a little more challenging, like the back here, it says write complete, balanced, jazzed up reactions. And so, gosh, what a skill. Who would have thought a couple weeks ago that if I gave you this sentence, you could do this? But boy, oh boy, you can now. When aqueous potassium nitrate is heated up, it will decompose into nitrogen dioxide gas, potassium, and oxygen. All right, so this is a decomposition reaction because we're having the potassium nitrate break down into nitrogen dioxide gas, potassium, and oxygen. So first up, I need to write the proper formulas. Potassium nitrate. Nitrate, polyatomic ion, is NO3 with a -1 charge. Nic, 3 oxygens, -1 charge. Potassium from your ion card, it's group 1, so it's +1. So potassium nitrate is KNO3. It is decomposing into nitrogen dioxide, di means 2, nitrogen dioxide, potassium, which is just K, and oxygen. Oxygen, of course, part of Hofbrinkel, so I have to put an O2. Of course, since oxygen is part of Hofbrinkel, it's a diatomic, so that's why I have O2. All right, so there's my skeleton equation, proper formulas. I need to balance now. I see that I have 1 K on both sides, 1 N on both sides, but I've got 3 oxygens, and I've got 2 plus 2, that's 4 oxygens. So this is not balanced. All right, I've got 3 on my reactant side, 4 on my product side. When I have that odd-even situation, that's when I typically have to double up the odd. So I'm going to double my KNO3. So that makes 2 Ks. So I'm going to make 2 Ks. It makes 2 Ns. So I'm going to put 2 here. And it makes 2 times 3, 6 oxygens going in. So 2 times 2 is 4, plus 2. I've got 6 oxygens coming out. All right. So now I have my balanced equation. Let me clean that up so that we can focus on the symbols. Okay, so now I just need to add symbols to this. I've got my proper formulas. I am balanced. So when I look, I see potassium nitrate is aqueous, and so I put an AQ in parentheses to symbolize aqueous. Then I see that nitrogen dioxide is gas, so in parentheses I put a little G for gas. And then I see potassium and oxygen. Now how am I supposed to know what symbol or what symbol to put there? And the thing that you should do, that, especially when we're talking about elements, look on your periodic table. Remember that your periodic table is color coded. If the symbol is black, it's solid. If it's red, it's a gas, and if it's blue, it's a liquid. It's at room temperature, but we assume that these reactions are happening at that. So potassium, when I look on my periodic table, is a black symbol, so that is solid. And oxygen is red, so it's a gas. And again, of course, for these you can put an upwards arrow instead of the G for gas if you'd like. Last thing is that it says the reaction is heated up, so above the arrow I can put the triangle or I write the word heat. And so there you have a complete, balanced, jazzed up reaction, including all of your symbols. And so you should be able to complete the rest of this worksheet with no problems. All right, see you soon.